Hi guys, I will go through the questions that we worked on last Friday. So um, still I don't know the workshop questions, and that's why I go through these questions, and maybe I will add a couple of other questions. So question one is about the basic notion of the probability, so which is given to you here. So you may stop the pause the video and have a look at the definition, although you have seen this one in your lecture notes as well. So a fair single die, the key is to be fair, and a die is a usually a six faces cube. So we know that, so to get any number, the probability of the any number, including just six, it will be 1/6. Okay, so the sample space for this one is S is will be equal to 1, 2, 3 until 6, and the desired one, which is E, will be just 6. So the cardinality of the E will be 1, and the cardinality of the omega or uh, sample space or S will be 6. So 1/6 is the answer of this one. Now, you might see this question, or I'm not sure actually. So this was similar to the question that last year in final exam. So every student needed to permute his or her student ID. So if you have something like 3, 2, 2, 5, 1, and 8, so the answer of this one 1, 2, 3, 4, 5, 6. So 6 factorial, but one of the numbers, yeah, it has been written, it has been like repeated, so you should divide it by 2 factorial. The other ones you don't need to do anything else, so 1 factorial for the rest. All right, question 2, back to the probability topic. We see that in the situation of tossing a single die, what do we call the sample space? So we know that sample space will be omega or S1, 2, 3 until 6, and the desired uh, event, or which is like getting even numbers, will be 2, 4, 6. And this die is a fair, and the chance of getting any number is equal with the other one. So every number will be 1/6. So the probability of getting this even number will be cardinality of this set 3 and the cardinality of the sample space. All right, so let's go through the question 3. But the answer for this one will be question part D, and I leave this question for you, so you can read this question, but um, it's not that complicated. And by the way, this question is not important. And now we see that um, two events, E1 and E2, they are independent. If we have probability of E2 condition E1 will be equal to probability of E2. All right. So in another way, have a look at here. Probability E2 condition E1, the definition is probability E2 intersection E1 divided by E1. And this is, we say that this one is independent if this is equal to probability of E2. And now from here, this fraction is equal to this one. So as a result, to be two events, E2 and E1 are independent if probability of the E2 intersection E1 is equal to, if and only if this will be equal to probability of E2 and the probability of E1. This is another definition of the being if two events are independent. Now, the example from lecture note is about 100 applicants for applying a teaching position. Some of them are married and some of them are not. And some of them are having a 3 years experience of teaching, so 12, and some of them doesn't have 3 years teaching. All right, so what is the probability that applicant is married and has at least 3 years? So married is this column, and 3 years, it will be 12 divided by 100. So the answer of this one is 12 divided by 100. It is written and it means married intersection with 3 years teaching. Okay, but given that applicant is married, it means we know that it's married. So what is the probability that he or she has got 3 years teaching experience? So given that, obviously it is conditional. So this means instead of having all 100 applicants, we restrict ourselves to this column, the married situation or married condition. So 3 years experience, it will be 12 divided by the total of this column. So it will be 12 divided by 30. But you can choose to 12 over 30, but you can do the formula. 3 years condition married means 3 years intersection with married. From part 1, we know that it will be 12 over 100. And being married means 30 over 100. So this will be 12 over 30, which will be the same answer. Now, let's have a look at this question. A box contains 3 red and 4 black balls. A ball is removed, inspected, and inspected means we see that it is red or black, and then we put it back. And we take the second ball. So what is the probability that both balls were red? So taking one ball, put it back, and do another one. So these two independent. The first ball and second ball are independent. So both red means 3 over 7 times 3 over 7, which will be probability of first one red, second one red, will be probability of they are independent. Probability of the first one times probability of the second one. So the answer is this one. Now, conditional probability, the definition is given here as well. Now, same question here. The box 3 red, 4 black, but this time we don't put back without replacement. It means without replacement. So what is the probability if both of them are red? So 3 over 7, and this time we can't say 3 over 7. We have removed one of them. So the total, the box contains only 6 of them because we removed one of that, and one of the red has been removed. So it means we have now 2 red. So the probability of the second ball be red is 2 over 6. So we multiply them by multiplication principle. So we get this answer, which is different than this answer. Now, let's have a look at slightly different question. Let's see. Without replacement here, this question, but what is the probability that at least one of them is red? So one of them red, at least one of them red, it means, so without replacement is this question, not this question. Exactly one of them red or 2 of them red. So exactly one of them red, it can be in the first box, 3 over 7 times 2 over 6. And it can be, then we've got first one can be black and the second one can be red. So 4/7 for the black, and the second second drawn ball is red. So 3/6 without replacement. Now, at least one. So we can see that we can get two of them are red. So it will be 3/7. Okay. And we will have 4/6. Okay. So this will be, the first one is 3/7 for the red and 4/6 for the black one. Okay. So this means like, all right, 3/7 for the first black here, first red here, and 2/6 is the second one is black. Now here 3/7 is, first one is the red and second one is black, 4/6, and here first one is black and second one is red. So to clarify, I can see that two red, first red, second black, and this one is first black, second red. It means this one. But we can do this question in different ways. So we can see that all of the condition scenarios is 1, probability of everything is 1, minus complement of this one, which is no red. So no red means 1 minus, the first one is black, 4/7, and the second one is black. So because we removed one of the 4 blacks, it means 3/6. So this answer, which is this, will be equal the first one. So sometimes it's better to use complement probability. All right. So an example from the lecture note, we shuffle 9 cards, and what is the probability 2 digits are numeral? The cards both greater than 70 and divisible by 5. So we've got 2 cards, 9 times 9, okay, or at least we draw 9 cards twice. So the scenario will be 81, and the desired one bigger than 70. 70 is not accepted. 75, 85, 95. We don't have 80 because we don't have 0. All right, so this will be probability of E1, 3/81. What is the probability that numeral begins with an odd digits and is even? So odd digits, 1, 1, 1, 1, 3, 5, and the rest is even ones. You can do in this way and you can count all of that. But so this will be 4 and 5 rows. So it will be 4 times 5. But probability of, we can do other things. First card is odd, so the answer is this one, 5/9. But the second card must be, because we put it back, the second, and we put it back the card. So the the probability of the second card is even, is 4/9. Okay, so this is 20/81. Because the first card, we put it back and we draw another card. They are independent card, independent event. Now here, box 1 contains 2 black balls, 2 white balls. All right, box 1, 2 black, 2 white, and box 2 is 2 black, 4 white. What is the probability of getting at least 1 black? At least 1 black means exactly 1 black or exactly 2 blacks. So exactly 1 black is this box 2/4, okay, and times second box will be white, okay. So one black one, the box one is black, box one white. So exactly one, we will have exactly one black, okay? Then exactly one black here, but this time we will get from this part, okay? So this will be 4/6. Sorry, this will be 2, and this will be 2/4 for one white from black's box one, and two of them are two of them will be black, because exactly at least one means it can be also two of them black. So this will be from here for box one 2/4. From box two it will be 2/6, and the answer will be this one. But we can do this one. We can use the complement probability. So it will be probability of the whole scenario. Okay, but and minus no black bulb. It means the first one y 2/4, and the times the second one white as well 4/6. So 1 minus of the complement of the at least one black. It means this one, and we will get the same answer as here. A sample of so by the way, I leave this part to you, okay, and the answer is 1/2. A sample of people were asked whether they approved of the president's job performance. So what is the probability that random person is a male, okay, and approves? So it means male and approves is this one. Given that, and it will be a conditional probability. 45 that they are female. So we choose from this part, but approves. So 45 divided by summation of 45 and 53. All right, and a random variable x is function. So it, which is a function from sample space to which is, and it is a real number. And we can use this one in some applications in probability. Now, a biased coin is probability of head is 1/3, probability of the tail, as a result, it will be 1 minus of this. And find the probability of the function for x will be, x will be based on the number of the number of the toes at which the first time we see tail. So probability of x equal k, so number of the toes, x will be number of the toes, okay? And x equal k, in the k times we toes, and we see in the case times for the first time tail. It means previously we had only head, so k minus 1 will be head, and all of them are tail. So it will be, this one will be probability of H, and we will get probability of the T. So we will get this one. So if we have probability of xk, so probability of H, each of them is 1/3, and this one, the last one, is 2/3, so 2/3. So the answer of this one will be this guy. Okay, so this is the end of the today's video, and let's see if I can make another video.